you, Leslie. That indeed is going to be a hard act to follow, but I promise somewhere in the middle I will give you a definition of nanotechnology. So I'd like to do a couple of things today. Tell you a little bit about one of our major centers here at UCSB called Mitsubishi Chemical Center for Advanced Materials. It's a little bit unusual in that it's a center that engages a single company with UCSB with multiple investigators, as opposed to many centers that engage multiple companies with multiple investigators. So this has been a 9-year odyssey with Mitsubishi Chemical, and unofficially, and I'm sure it won't leak out of this room, they've agreed to a 4-year renewal of this center starting in next year in 2010. And I may say a few words about this Kaiteki Institute, because in some ways it's related to the MCCAM experience. So first of all, who are we dealing with? When the word Mitsubishi comes to mind, most of you think automaker, consumer electronics company, high-end audio and video kind of equipment. We're talking about the chemical company. At the top level is an umbrella organization called the Mitsubishi Chemical Holdings Group. They have 3 main legs underneath the holding company. Mitsubishi Chemical Corporation, which is itself about a $22 billion corporation, has about 350 subsidiaries, many of which are only partly owned. It's kind of a mess under there. But you have everything from really basic petrochemicals to high-performance materials, materials for solid-state lighting devices and things like that. So it's everything from kind of basic chemicals to performance chemicals and materials. There's a reasonable-sized plastics company called Mitsubishi Plastics, about $4 billion a year in sales, and then there's a small pharma company, Mitsubishi Pharma. So you can see they're sort of broadly across chemicals, materials, performance materials, and even the healthcare sector and pharma sector. And in aggregate, about $30 billion a year in sales. So this relationship with UCSB started in 2001. This is a handshake that took place in Tokyo in January 2001. The fellow on the left here is George Stephanopoulos, who was the CTO of Mitsubishi at that time. He's also a chemical engineering professor at MIT. Had taken a 2-year leave of absence from MIT to go to Mitsubishi and be their CTO. And he was charged with developing significant external research relationships for the company. And he made the decision to do the first major alliance with UCSB. And you see him shaking hands with Matt Kukal, who's a former dean, and it's Henry Yang, our chancellor. Mitsubishi's motivation was they really wanted to develop an in-depth, broad research relationship with our materials community, which spans many departments at UCSB. And from our side, it was not only the funding that was of interest to us, but it was the ability to partner with a major multinational corporation who's involved in developing lots of advanced materials. And so the vehicle for this that we created is this MCCAM Center. And we started in 2001, initially had a 5-year research agreement with them, renewed in 2006, another 4 years, and we've just got another 4-year renewal for starting next year. It's interesting to think about why did they choose us. It usually starts with some kind of a personal relationship. Turns out George and I had been on an advisory board at Dow Chemical and gotten to know each other, and through me gotten to know UCSB and the materials community here. And it's a deep materials community. I mean, there are probably 60+ faculty on campus who do some kind of materials research. As Larry indicated in his talk, we're ranked very highly in materials. UCSB is regardless of what metric you use, we're in the top 5 in the world in material science research. The other thing that we've done very well here is we have really world-class equipment, and we share equipment, which is something that most places don't do. And we have a very interdisciplinary, collaborative approach to doing research. And this is a little bit outdated diagram that the materials department used to use to kind of illustrate this. But if you basically list faculty who are involved, who have some kind of a partial appointment in the materials department, that's everybody who falls in the yellow region. And the interesting thing is you only see about 5 people with a 100% appointment in materials. Most of our materials-related faculty have joint appointments in different departments, and that breaks down barriers. It basically makes kind of one big seamless materials community, so it's very easy to engage teams of researchers to go after whatever problem that you're interested in solving. And on the university side, we actually, in spite of the difficult reputation of UC for providing research contracts, we found that we were able actually in about 4 months to put together an intellectual property agreement for this whole program. And it's basically stayed intact since 2001. This is the structure of the center. It's basically a center under the College of Engineering. Mike Witherall is Vice Chancellor for Research, also has a number of research centers under his unit. We decided to keep it in the College of Engineering, even though it engages a lot of faculty out in the sciences outside of engineering, is because we decided to tie it to another existing materials center, the Materials Research Laboratory, currently directed by Craig Hawker. This is a NSF-sponsored research center. It has a very different mandate, mission, has educational programs in addition to research programs. But in the end, they do similar things to what we do. They basically set up, execute, fund research projects and hold events. And so what we decided to do was to put the 2 centers together to basically leverage staff between the 2 centers. The difference is that the MC-CAM Center has an intellectual property umbrella over all of the research programs. The working end of MC-CAM is actually a committee of 10 people with 5 Mitsubishi scientists and managers and 5 UCSB faculty who actually decide how the money gets spent on research projects. And the money has been fairly substantial. Basically, Mitsubishi has been providing about $2 million a year on an ongoing basis to directly fund research. They've also contributed a couple of $1 million in philanthropy for chairs and graduate student fellowships and that sort of thing. But over the 9-year period that'll run out next year, it's been about a $25 million investment at UCSB, a very substantial investment. Actually, there's more money under the Solid State Lighting and Energy Center that's not even reported here. One unique thing that happened here was that as a result of this commitment by Mitsubishi, the administration actually gave a significant amount of the overhead back on the original 5-year grant for the purpose of building space. I mean, that's something that most of my academic colleagues who've experienced other universities would find that astounding, that administrators would ever give overhead money back for the benefit of the program in these significant amounts. And in this case, it allowed us to build a $5 million addition on the MRL building to at least partially house this program. How these projects worked, one thing that has been very important in the success of this is that every project not only has a PI at the university as a project leader, but has a co-project leader from the company. And that person monitors the project on both a quarterly basis, we report quarterly on the projects, but in many cases is much more involved than that. Mitsubishi also set up a small office in Goleta with 7 PhDs in it, who are basically our interface to all of their corporate research labs in Japan. Many of the people